D2DNY, Real World HVAC Simplified. And now, in this video, I am going to be doing a commercial HVAC service call on a Liebert DS unit. So I'm going to be doing a step-by-step troubleshooting on this particular video. Alright, so there's the toolbox. Alright, so here is the current alarm. It says the current alarm is main fan overload. Alright, so clearly you can see the alarm light is red, it's flashing. The temperature is high, 81 degrees. The set point is currently 70 degrees. So definitely there's a problem. Alright, so stay tuned, go with me through this diagnostics, and we're going to be doing it together. So in order to open this unit, you will need a Liebert key or an Allen key like this. See, fits. Alright, also you can see my alarm relay. Yeah, this is the alarm relay right here. And that's on. Alright. So that's the main board in the unit. First thing I'm going to do, I'm going to go over to the schematic, and I'm going to see what's involved for the main fan on the control side. Okay, so stay tuned. Now here I am with the schematic. I'm in the electrical control section. This is the electrical high voltage section. That's the low voltage control board. So on the schematic here, here you have triac number 5 right here, Q5. That feeds the main fan. Alright, so right here, Q5, main fan triac, right? So let's go and see if our Q5 main fan triac is on. And let me turn the lights off. Okay, so right now we got this right here. And you can see that the green LED is on. This right here is Q5. As you can see, it says Q5 on the board. Alright, so the triac is on, it's closed, it's passing 24 volts to the main fan contactor. Alright, so let's just see where we get that alarm. So get the lights back on. So right here, we go back to Q5, so 24 volts leave the triac. Alright, and it immediately goes over here, and you can see there's an overload right here, main fan overload, which is currently what the alarm is saying. And so the 24 volts continues all the way, and it branches off right here and it goes here. Now here is where the alarm point is. If this terminal doesn't receive 24 volts while the main fan triac is closed, then it's going to generate an alarm for the main fan overload, because once again this line right here goes back into your fuse, this 24 volts, right, coming off of your transformer right here. If you're a pro, you will know this is a symbol for a transformer. 24 volts. If all your fuse is good, if this particular fuse right down here is closed or good, 24 volts is able to pass through all of this right here. And I had already verified that there's power on this line, because this input right here on the board, U23, is lit. So U23 is 22 right here, 23 right there. Okay, and there's a green light lit on that input. So if that green light is lit, that means 24 volts is there. So we're getting 24 volts. All right, so our main fuse is good, and this is where the main fuses are. And I could see all of them is lit up. Those green lights on the fuses, they're all on. So all my fuses are good. My fuses is good. So we verified that we're getting 24 volts on U23 because that input is lit up. So that means 24 volts is passing through my triac, which is currently on. So we got this bit right here. There's another safety in line. So the 24 volts stops right here, because if it didn't, it would have passed. It would have got to this splice or connection, and then also now my U22 on the board would be lit. So U22 is right here. And as you can see, U22 is not lit. So there's no 24 volts power right there. Hence the reason why this board is in alarm. Okay? The unit is in alarm for the main fan failure. Right? Again, 24 volts is right here. Clearly we know this. And I could check with my meter on the board at this connector. Connector 40 and wire number 12. I could check. Usually these things are really good with the indications, so I trust it. So here is where we have the alarm, because this input is not seeing 24 volts while this track is closed. Okay, so that's Q5 is closed, and so that's why we're getting the alarm. So now I'm going to open up this unit and I'm going to go in and I'm going to check on the main fan. There should be something there that's going to show me or overload that's going to be open. So stay tuned. Next phase of the troubleshooting. So to access the main fan, you're going to have to open these right here in the bottom. So I got to open these with my Allen key. Alright, so stay tuned. Let me remove this cover. Okay guys, so I'd remove these panels, as you can see. However, the main fan is not down here. It is behind here. But you can see it's on the other side over there. It's in the corner. So I'm gonna have to go around. And it's a bit strange that Liebert did this, because you know I can't use my Allen key in this corner. You know, you gotta take out and use that. Looks like a 3/8 nut. So anyways, I'm gonna get to it and then I'll resume. Stay tuned. Okay, so there's another panel back here. Got to take these out. These looks like 1/4 inch. All right. If you have not subscribed, please do so right now. If you haven't subscribed, subscribe, and then hit that notification bell so that when I upload videos like these, you get them right away. Okay, so do so right now. I'll wait for you. Before I get into this unit, before I open this last panel, subscribe right now. Smash that bell icon. Okay, so here is your main fan, or evaporator fan as you may. Evap fan. There's your blower, squirrel cage, flywheel, our blower assembly. This is a belt driven blower. There's your motor nameplate. It's actually upside down. Alright, so I'm going to go ahead and open up the pecker head right here. And these looks like 3/8. And we're going to see what's inside. There should be a safety or a sensor in there that's preventing this fan from running. Must be tripped. Okay. I remember some of these units, they actually have a button on the motor which you can press to reset it when it's tripped. But I don't see any button on this one. This right here is for greasing. So I'm going to open up the pecker head and see what I see. Alright, so stay tuned. Yep, luckily it's the same 3/8 screw. Alright, so that's open. And I don't see any sensors in here. Okay, so what's going on? I think I'm going to have to take my meter out because this motor does not have any overload whatsoever. This is just 3-phase. There's no safeties in here. Low voltage. This is line voltage. Yeah, it's getting very interesting, guys. So stay tuned. I'm gonna get my meter. I'm gonna grab my meter and start checking the wires as they leave the schematics, where they go, and see where I'm losing my power. Okay guys, I think right here this is the main fan overload. There's a main fan contactor. So on other versions of Liebherr, they'll have an actual button on the motor. So I was assuming it was the same thing, but this right here is it. Main fan contactor, and this is the overload section, almost like a starter, but it's just the contactor and the overload section is separate. So I'm going to assume that these two, this is the controls, low voltage, and I'm assuming that these are open right now. I'm going to grab my meter and I'm going to test it. All right, so bear with me. We're doing this troubleshooting in real time. I suppose I could just press this button and reset it, but I don't want to do that because I got the panels open. All right, so I want to button everything back up, and then I'm just going to check that overload contacts, and then if the contacts are open, I'll hit the reset, measure the amperage. I'm going to check the windings of the motor, but I'll do it from the fan contactors because you don't have to do it right here. All the connections are solid. So I had to open this anyways because, if the overload is tripped outside in the panel, it could have been because you have a loose connection here. So, as a good practice, I'd have to come in here anyways and check this to make sure that my connections are solid, and they are solid. No problems here. Everything is good. So I'm gonna close this back up. I'm gonna go test with my meter that to make sure that verify that those overloads contacts in fact are opened, and then reset it and then do some amperage reading. But like I said, before I do that, I want to make sure I ohm the motor out, make sure there's no ground fault, there's not grounded, nothing grounded on the motor windings. I won't use a meg tester or mega home meter. I'll just use my regular home meter and just check for ground and that the windings of continuity and then I'm just going to reset it and then check the amperage. I'm going to match the amperage of the nameplate versus what it's drawing. And perhaps that overload, as you could see, was adjustable. Perhaps it just needs to be adjusted. That's all. All right, so stay tuned. All right, so I'm gonna grab my meter. Got the panels put back in. The small panel, that is. The big one is still off. So I'm just gonna grab my meter and I'm gonna do some testing on the motor winding. Make sure the motor windings are not shorted to ground and they are not open. I'm gonna check my power supply coming into the main fan contactor, make sure that my fuses are good and that my power supply is good. And then I'm going to, because all this could lead to the overload being tripped. And then I'm going to, you know, just to verify, I'm almost positive that I'm going to find that those contacts and the overloads are open. Okay. So yeah, I mean, listen, if you're not subscribed, do so right now. And smash that bell icon so when I do videos like this you get them right away. Okay, so I'm gonna go first. I'm gonna check my contacts on the overload. And you can see that I'm reading 24 volts potential across the contacts. So these are open for certain. And these are supposed to be normally closed, or NC, as you can see right there. NC, baby. All right, so I'm gonna go ahead and check my, because you know I have 3 fuses that feeds the main fan. I'm gonna check to make sure that they are closed and my power is good. All right, so that's good. That's good. All my 3-phase fuses are good. I'm getting 3-phase power. Okay. See real time. All right, so that's checked out. So now, before I hit the reset, I'm going to go ahead and check the windings of the motor for resistance. All right, so those are closed. Another 2 pairs. Those are closed. All 3 windings are closed. I'm going to go to ground now. So I am good. Nothing is grounded. Just with my regular meter, nothing is grounded. Doesn't mean that the motor doesn't have an electrical fault, because I'm not using a mega home meter. But anyways, I'm gonna go ahead and I'm gonna reset this and check the amperage when the fan starts. Currently, this dial that looks like it's set for 25 amps. It's like 25 amps. It's 23, 24, 25, 26. Yeah, 24 or 25 amps, somewhere in that neighborhood. So I really don't know what happened here, guys. Why the overloader tripped. Because it's only running at 18.5 or 18 amps. And now you can see my U22 has been satisfied. There's a green light there, right? Okay. And you know, other tracks is turned on now. The compressor right here, they're turned on. Yeah, so I mean, it's a bit strange that maybe this thing is faulty. Because I'm running well below. Let me check my other lines. 19. Yeah, it's looking good, guys. I don't know why this thing has tripped. It's running well below the trip settings. I hit the test button right here. Start it again. I think this thing may be faulty. Has to be. Because again, the set point is all the way at 24, 25 amps and we're only running at 18. So my main fuses are good, intact. Yeah, I'm gonna say that this thing must be faulty. It has to be faulty. All right. So now, if you like this video, give it a thumbs up. If you have not subscribed, please do so right now. I do upload videos on a weekly basis. I'm going to be monitoring this for about 30 minutes or so to see what happens with the amperage. And I'm also going to go grab my my mega ohm meter, and I'm going to meg out this motor just to make sure the windings are in the clear. And if that is in the clear, then I'm just going to recommend to replace this overload, motor overload. That's going to be the diagnostics, and that's the diagnostics. And that's going to be the recommendation. I don't see why this was tripped. Either this is faulty, or the motor windings is going to be failing my mega ohm test. It passed okay with this meter to ground. However, it may not pass with the mega ohm meter. And actually, what I'll do, I know that the voltage coming in has to be good, because if there's an imbalance in voltage, more than likely I'd have blown a fuse. So I am going to, in addition to replacing this overload, I'm going to replace the main fan contactor as well. Okay, that's going to be my recommendation. Yeah. So again, if you would like this video, if it had helped you out, if you find value in it, give it a thumbs up. And if you have not subscribed, please do so right now. I do upload videos on a weekly basis.